Hello everyone. Today we are going to analyze this simply supported beam. In this beam there are two uniformly distributed loads having the magnitude of 14 kN per meter. Both of them are acting for a distance of 2 meter from both of the ends. In the center of the beam there is a point movement 30 kN meter. It is acting in the clockwise direction. To find RA, let us take a moment about B. In this case, we have to follow right hand side rule. RA is acting in the clockwise direction, so it will be positive, and the distance is 2 plus 1 plus 1 plus 2, so it will be 6 RA. This UDL is acting in the anti-clockwise direction, so it will be negative. For the UDL, we have to multiply the area with the centroid distance. We know that the UDL is in the shape of rectangle. We know the area formula of a rectangle, that is length into breadth. Here the length is 2 and the breadth is 14. So this is the area. And we know that the centroid of a rectangle lies in the center. So from the center to the point C, the distance will be 2 upon 2. But we are taking moment about B. So we have to add the remaining distance as well, which is 1 plus 1 plus 2. So it will be 4. This movement is acting in the clockwise direction, so it will be positive. This UDL is acting in the anti-clockwise direction, so it will be negative. The area is 14 into 2, and we know that the centroid lies in the center. So from the center to the point B, the distance will be 2 upon 2. For RA, we will get 23 kN. To find RB, let us take a moment about A. In this case, we have to follow left-hand side rule. RB is acting in the anti-clockwise direction, so it will be positive, and the distance is 6, so it is 6 RB. This UDL is acting in the clockwise direction, so it will be negative. 14 into 2 is the area, and the centroid distance about E is 2 upon 2. Since we are taking moment about A, we have to add the remaining distance, which is 1 plus 1 plus 2, so it will be 4. This movement is acting in the clockwise direction, so it will be negative. This UDL is acting in the clockwise direction, so it is also negative. The area is 14 into 2, and the centroid distance about A is 2 upon 2. For RB, we will get 33 kN. Alternatively, using this rule, we can find RB very easily. RA and RB are acting upwards, so both of them are positive. Both of these UDL are acting downwards, so both of them are negative. For the UDL, we have to take the area 14 into 2 and 14 into 2. For RB, we will get 33 kN. To find the shear force at A, C and at E, let us use right hand side rule. No need to find the shear force at D, because there will be no change in the shear force due to the point movement. Shear force at just left of A will be 0, and at just right of A will be RA, which is acting upwards, so it will be positive. Let us find the shear force at C. RA is acting upwards, so positive. This UDL is acting downwards, so it will be negative. For the UDL, we have to take the area, which is 14 into 2. For the shear force at C, we will get minus 5. Let us find the shear force at E. Up to the point E, we have only RA and this UDL. So here also we will have the same shear force minus 5. Using the left hand side rule, let us find the shear force values at B. Shear force at just right of B will be 0, and at just left of B will be RB, which is acting upwards, so it will be negative. Here you can see the shear force diagram. In this point the shear force becomes 0. So in this point under the UDL, there will be maximum bending moment. We have to make a section and find the distance. You can see that in that point I have made a section XX at a distance of X from A. Using the right hand side rule, let us find the shear force about the section. RA is acting upwards, so positive. The UDL is acting downwards, so it will be negative. For the UDL, we have to take the area. Up to the section, the area of the UDL is 14 into X. We know that in this section, the shear force is 0. For X, we will get 1.643 meter. Using the right hand side rule, let us find the bending moment about the section at C and at D. Let us find the bending moment about the section. RA is acting in the clockwise direction, so positive, and the distance is 1.643. The UDL is acting in the anti-clockwise direction, so negative. The area is 14 into 1.643, and the centroid distance about the section is 1.643 upon 2. For the moment at the section, we will get 18.89. Let us find the moment at C. RA is acting in the clockwise direction, so positive, and the distance is 2. The UDL is acting in the anti-clockwise direction, so it will be negative, and the area is 14 into 2, and the centroid distance about C is 2 upon 2. For the moment at C, we will get 18. In the point D, there is a concentrated movement, so we have to find the bending moment 2 times, at just left of D and then at just right of D. First, let us find the movement at just left of D. RA is acting in the clockwise direction, so positive, and the distance is 2 plus 1, so it will be 3. The UDL is acting in the anti-clockwise direction, so it will be negative. The area is 14 into 2. The centroid distance about C is 2 upon 2, but we are finding the moment up to D, so we have to add the remaining distance, which is 1. For the moment at just left of D, we will get 13. To find the moment at just right of D, with this, we have to add this concentrated movement. It is acting in the clockwise direction, so it should be applied as positive. For the movement at just right of D, we will get 43. To find the movement at E, let us use the left-hand side rule. RB is acting in the anti-clockwise direction, so it will be positive, and the distance is 2. The UDL is acting in the clockwise direction, so it will be negative. The area is 14 into 2. And the centroid distance about E is 2 upon 2. For the movement at D, we will get 38. We know that in the simply supported ends, the moment will be 0. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.